So please only watch this video if you've already implemented and got working a simple camera. Otherwise, these things really won't make much sense. So please start with that. I really mean that. Okay, so this camera, we've added some additional things. The first thing I've added here is that we can actually move a bit of a distance in the middle before the camera starts moving. And when we get far enough along, then the camera starts moving. The other thing you'll probably notice is that the camera is delayed a little bit. So if I start, the camera will then slowly catch up. And then when I stop, the camera keeps moving and slows down and eventually stops. So it's a nice, smooth movement. So how do we implement these things? Well, we're going to add to our previous camera code here. And when we're defining our camera object, I've had to add some more things. The X and Y now is the actual position of the camera. The target X and target Y are where the camera's moving to. So if I've stopped moving, but maybe the camera's still moving towards a particular target, this is the target it's moving towards. The X drag and the Y drag is how far I can move left and right before the camera starts to follow. And the smoothing is how much the camera doesn't just instantly follow the player. It has a gentle, smooth movement. You can play around with that number. Somewhere around 0.9 will be good. Anything less than 0.8 probably won't even be noticeable if I remember correctly. I could be getting that wrong. All right, now this is a lot more complicated than last time. So let's just talk about the differences in conceptually what's going on. In the previous code, if you'll remember, that we set the camera to stick with the player. But in this case, you'll notice that we're actually allowing the player to move a little bit before the camera starts moving. So we're just going to clamp the camera within a particular range. And that depends on what amount of drag we're allowing the camera to have. So it could be, for example, up here, it waits 30 pixels before it starts moving. So that's the difference there with the clamp function. And just a reminder, the clamp function isn't built into MicroStudio, but it's in the pack that I've given to you. The other thing you'll notice is we're not moving the camera directly now. We're moving camera.targetX and camera.targetY. And the reason for that is that we want to implement that smoothing into that target position, which we'll do later on down here, this code here. Then we've got the level limits, which are similar to before. This is very similar to before. I've just done it in a more sort of professional way, I guess, where I've defined an X limit and a Y limit. And I've actually done that mathematics I suggested last time formally here, where I've said we get half the level width and then we subtract half the screen width. But you don't have to do it this way. It's just very nice because you can change, you can change these level or the maps quite easily. The final thing here is that we're going to move the camera towards its target slowly. So what we're going to do is we're going to get camera.x, so that's the actual position of the camera, and then we're going to add on to that the camera.targetx minus the camera. So this here is the distance between the camera.x and the target camera.x, so how far it has to go. And we're going to move, and we're going to increase our camera by, we're going to times it by 1 minus camera smoothing. Now, again, I wouldn't worry too much about the mathematics behind that, but basically, with our smoothing of 0.9, what that means is that every frame we're going to move 10%, because 1 minus 0.9 is 0.1 or 10%, we're going to move 10% towards our target every time. So you can sort of imagine that if you're 10 pixels away, the first frame you'll move 1 pixel towards it, and then you've got 9 pixels to go, so the next one you'll move 0.9 pixels towards it. So and so on and so forth, and then you'll move very quickly towards it, but slow down, slow down, slow down until you get to the the target. The problem with that though is that mathematically, because it's slowing down all the time, it looks nice, but you'll never actually get to the target mathematically if you're always moving a fraction or 10% towards it. So when the distance ends up being less than 0.2 pixels, then we just set the camera to where the target is. So it'll move quickly towards its target, the camera, and then slow down, but when it gets to within 0.2, we'll just snap it there. Otherwise, you might get some weird effects as it moves at ultra slow speed for an infinite amount of time, which is a little bit weird. Again, a lot of these things are very complicated. You should get, though, with the camera, a lot of success if you just copy this code correctly and have a vague idea of how it works, if you're interested in getting these nice effects. Anyway, I hope that helps, and good luck with yours.